Is that working? Clicker is. Can you check if the clicker is working? Yes, start. You ready? Etherpad. Etherpad. Yeah. Look. Yeah. Take the notes on my Etherpad. Good afternoon. This is the TEAS working group hosting the joint Yang session with CCAMP, MPLS, and PCE. You can access the agenda for today and the slides using the pointers on the slide. IETF Note well, this is Thursday afternoon. You should be well versed by this by now. Lou has presented the recent changes to this Note well a couple of times this week. This was presented in the MPLS working group and also in the routing area open meeting. If you missed those two presentations, please do give this a read. As far as session logistics are concerned, this session is being streamed and recorded, so please do speak only using the microphones and do state your name before speaking for the benefit of remote participants. As usual, we will be taking the minutes using Etherpad, so please do participate in it, and we'll be on Jabber as well. As far as agenda for today goes, we have 3 slots dedicated for T-specific drafts. There are a couple for CCAMP. There's one that discusses generic Yang infra enhancements, and we'll finish off with an update from BBF. First up is an update on the T topology draft. Shifeng.
Good afternoon. I'm Xifeng Liu from Vivo, reporting the status of the TE topology models. On behalf of the authors and contributors, we still have our regular meetings weekly, but we even got more contributors. But the changes, okay, hi. But the changes are getting minor now. So the models are stable, and we hope to publish the model soon, as requested by the implementers. So here's the list of changes we have made since the last IETF session. So now we allow multiple instances of inter-layer lock IDs, and we added the missing TTPs to the underlay, and we add some attributes to the link termination point and tunnel termination points. So we also import handling of connectivity metrics labels, and we import the sharing of the TE types between our topology model and TE tunnel models. We also have redone the generic bandwidth modeling. So now we have addressed the Young Doctor's review comments, and we have updated the model to the NMDA style. Then here's some of the changes we mentioned earlier. So here's inter-layer lock ID. So we fix the situation. We need to support multiple lock IDs on each particular termination points. Here we changed the interlayer lock ID from leaf to leaf list. So this will accommodate this situation. Like here, for the case here we have TTP3, which need to have 2 lock IDs, 1 and 2. Then we requested by some implementers, we added a few attributes to the link termination point and tunnel termination points. So we already have administrators and names on many entities, but they are missing here on the termination points. So added them here. In the underlay tunnel cases, sometimes we need to specify the underlay tunnel termination points. So we added in the model here so that we can specify such kind of requirements. Then for the connectivity matrix label handling, we were raised by situation there when the region get involved, the label from one end may be changed at the other end. So for the modeling, we need to move the label relationship sets, the label restriction from the matrix entry to each termination points. Then we have been doing this all along. So we try, because we have so many similar things to share between tunnel model and the topology model. So we moved whatever we can share between the two models into the TE types. Recently, we have done the three groupings here, path constraints, optimizations, and computed path properties. For those things, they are now in the TE types. Probably Tarek will talk more on those in the tunnel model presentation. Then for the bandwidth modeling, we have been this had been discussed before, and we got comments from CCAM people. He is also some more comments from Sergio and Carl also suggest that we should do more detailed modeling. So here we have inside of a generic string, we now have the groupings. So we have that better model here. And then we have the model reviewed by the young doctor. So we addressed all the concerns, including the presence containers, terminology consistencies, and some groupings. Then the bigger issue here is the NMDA style. And we have been discussing this for quite a bit of time. We all know that this is the direction we want to move to. This will provide a better structure and better features. So, but the question is how and when we can move to this kind of architecture. So we now, a couple of months ago, we already published the NMDA guidelines. So this is the way we're trying to move from current model styles to the NMDA. So the proposed guideline is like this. So if we need have the in use the state, which is the case we are having now, then we can have an NMDA module at the left, and also a companion state module on the right. So a big portion of those can be shared between the two models, and we noticed that there are a few differences there. So the module name is appended with the state, and the namespace also changed a little bit, and the config was not needed anymore here because everything is a config file on the right side. So this is well, at a glance, though the changes not that much. We can reuse pretty much everything here, but depending on the model complexity. So this is a trivial case. It's easy, but for our case, it's not that easy. We need to do some restructuring. And here, so we have had many discussions. So see when and how we want to move there. So we want to have our modeling capability. We need to maintain the our state and configure all those feature capabilities from the modeling perspective. We also need to retain the protocol and the application features, right? So we don't want to have a model delayed, and we also don't want to have a big impact to implementations. So Now, since we, after the many discussions, we decided to move this as quick as possible. So because we are depending on the topology-based model, which is IETF topology model, so we have discussed with this with the IETF topology model people, and the IETF model has agreed to update to NMDA, and thanks to Alex, this has been done. So then because of that, it's possible for us to move to NMDA also. So we have made change. So I did moved our model to the main NMDA configuration module, and then we also added the state module. The state module here, because we have used a lot of libreofs which contains XPath, so it's not that easy to simply reuse the grouping. So we have to do something to separate them out, restructure the groupings. This may not be the same case for every model, so we'll see later on some augmentations could be easier. So in our case, the NMDA model and the before NMDA model pretty much same size. The state model, we have some duplications, but it's tolerable here. We have like 15% things need to be repeated. So basic change is like this. So you have used to have config container and state container. Then we have moved all those attributes from the containers inside the config and state, move to the parents and remove those containers. So this is a simplified, pretty much showing what we have been doing. And then pretty much we have the current state of a model. So we think it's pretty much stable, and we're asking for the last call. So after this model, we have two other augmentation models. Right? So one case is the layer 3 T topology. This model is both augmentation T. Right. So that's the augmentation to the T topology model. And we have a reference model here, as layer 3 T topology model, which is referencing both the IETF layer 3 topology and the T topology. So they also have been updated to the MDA style because they are a little bit different, right? For the augmentation cases, you see here, and it's pretty much some data points for the moving to NMDA. So the NMDA module, a little bit reduced because we don't need to have a state. It's reduced size. And then we have some duplications in the state module. For the referencing case, we don't have any changes to the config module, but the state module it can be fully reused.
Rob Wilton, Cisco. So it's just a quick comment on producing the state modules. I think you sort of produce them by hand, right, and you try to optimize the size of them, which is fine. That's okay. But just as a sort of general observation here is the expectation is you can produce these very, very easily, just by taking a copy of the NMDA module, copy it, change its name to -state, change the namespace to -state, right, and reshare the type def and keep the grouping separate. And then the intention isn't to make that state module very short. It's intended to make it very, very easy to produce, throw it in the appendix and you're done. So I think it's fine to optimize it, but just to say it should be easy to produce as well without having any handwork doing it.
Right, size is one factor. Also, we don't want to have duplications, right? So it's a maintainability issue. You don't want to have changes here and there, because if you only try to search and replace all the namespaces, we have like hundreds of cases, right? So whenever you change the config model, we need to do the same thing again at the state model. Yeah, so we're hoping you have the tool which can make it fully automated, but now we don't have this. Okay. And we don't want to have these duplications there, so we want to minimize the impact. Okay,
okay, so that sort of makes sense. And the tool I'll check. I think I'm probably not far away from it for
Yeah.
that to be able to work to generate the state module for you,
Right.
because it's a fairly simple transformation.
Yeah.
I think, again, just an observation to the room, that the state modules here are a temporary thing. So this is not a long-term plan for these state modules to hang around. Once the NMDA compliant implementations come along, the state modules are automatically effectively deprecated and no longer required.
Yeah, yeah. Eventually, when the netconf and the redconf updated, hopefully we don't need to have the state module. But however, for some protocols, if they don't want to support the multiple data stores, this still will be needed.
If they choose to, so yeah.
Yeah. And another observation is that when we restructuring this, we hit the limitation for the grouping, because the grouping, you cannot pass parameter to that. So even though we have simple differences between the two structures, one is the namespace T topology, another one is T state. So if we can do some simple C kind of macro, this would easily can be reused, but this is not possible here.
Hi, Shupeng. My name is Tariq from Cisco. So the proposal of adding a module with a dash state, my understanding is to hold the applied configuration or state, and that's my understanding.
Yes.
There is a third argument to this, or is another state, which is a automatic or dynamic state.
Right.
Is the thinking that we will have a dash dynamic module there? And the second part of my question is, if augmentation, other modules will augment your model, they will have to augment
Both.
the model and the dash state model,
Yes.
and maybe the dash dynamic model.
Right.
So that's my concern.
Rob Wilson, Cisco. So the state module serves two purposes. One is it allows you to report the, before the NMDA implementations come out, it serves two purposes. One is it allows you to report the applied configuration value. The other case where it's used, and the case that probably matters here, is system-created interfaces and system-created state effectively. So it's required in that particular scenario.
Right.
To address the other comment about dynamic, no, there's no intention there'll ever be a /dynamic. I think the intention there is you require an NMDA compatible implementation to work with dynamic data stores. This is a transient thing.
Right, but there are implementations that support dynamic creation of objects. How do we, until NMDA comes, what's the state?
They just go in the state tree.
Stay as is.
Yeah, well, they go to hyphen state.
But that only stores the applied configuration.
Can you use the mic, Tariq?
Yeah, so the dash state, my understanding is holding the applied configuration, but not the dynamic configuration.
Igor Briskin, Huawei. It's a good discussion and it's a good general discussion. But for example, in the context of T topology model, a lot of things we do not simply consider. We do not consider dynamic data stores for one.
Yeah.
Okay, we only care about state and config. Yeah.
Luberger, anyhat. Just to be clear, the recommendation that came from the ADs and that is being followed through in all these different working groups is that the dash state model, the one that goes in the appendix, include both applied and system created information. So system created could be dynamic for a particular model. If for some reason that's insufficient and there needs to be a representation of a third thing, we should talk about it in that specific case. But at this point, no one's identified that third thing that can't be addressed by this approach during the gap, during the transition period.
Sue Hare's, I think in this hat, I'm I2RS chair with the topology dynamic piece. The benefit of the topology model with the NMDA, well, that's a tongue twister some days, is that it can be loaded in the dynamic ephemeral data store without problems. The dynamic data store is a unique definition. I think you need to be careful to disambiguate between dynamically created stuff and the dynamic data store.
Yeah, for that, those are the same thing we did for the SR and SRT topology models. We also moved that into NMDA compatible modules. And so in this case, this is a fully augmentation, so which is similar as before we mentioned. This bit reduced size of NMDA, and we have a state module, which is we don't. In this case, we don't have reflex and don't have active, so we use a pretty easier. So the size is minimal. So pretty much that's all we have.
Two hairs, I guess, in this case, IDR co-chair hat. Are you we're working to make the, there's a deployed non-MDA BGP model which hopefully is a basis for the SR additions to BGP.
Yeah.
But we are working rapidly toward an MNDA model. Are you anticipating data coming from a BGP NMDA based model plus an augmentation for service routing to be to be linked to your SRTE topology model you found?
Right, here the SR portion, we are using the groupings from the SR YAN model, segment routing YAN model, which provides us that groupings. So in that case, the SR model, I think they are already working on that to make it an NDA. So that's no problem. In terms of the BGP, that's your IDR issue, right? So we ideally we should move that to an NMDA also, but the how and the when.
No, it will be moving to MDA. I have heard my ADs, and I am a chair, and I got to obey. Yeah, we'll go there. Okay, but the question is more for technology basis.
Mm-hmm.
It looks like as a guiding chair, I must make sure that it all, we use the right types and all this stuff. If we do an SR extension to look at stuff, I need to make sure the models align carefully, and they all should align based on an NMDA.
Yes.
Did I understand that?
Yes, that's right.
Thank you very much for that clarification.
So this model currently doesn't take SRT policy into account. So
Pardon?
this model currently does not take SRT policy into account. The one that Shufeng just presented.
I wouldn't anticipate that BGP SRTE topology would be in its. Oh, let me ask the question. Clarifying question, Pavan. There are two types of policy: BGP policy related to SRTE and basic SR topology. Which one were you implying in that last comment?
Right now, all this does is add SR specific extensions to a T topology. In terms of T policy mapping, that's not covered here.
Okay.
But yeah, we can have that discussion and see where exactly that needs to be modeled.
Okay, another thing we probably need to align probably needs to be independent, but that's just the chair's initial guess. I'm not the authors.
All right. Thank you.
Thanks. Tarek?
Hello, everyone. My name is Tarek Saad, and I'm with Cisco Systems. Can you hear me okay in the back? I hope so. I can come closer. So I'm giving a quick update on the modeling effort for TNRZP models that are described in 3 drafts at the moment. The latest Yang code sits in GitHub at the location I have there. This presentation was done on Tuesday as well by my colleague, and this is a rerun. Basically, I can go faster a bit But please do ask questions and stop me if you have anything to clarify. So I'm going to go over the updates to the drafts, and then open issues and next steps. First off, I'll go with the updates to the TE model. So before I describe the changes we've done, let me give or recognize the efforts by Sergio, Italo, Carlo, Francesco, and others who reviewed our model, gave comments, and I hope we addressed and will continue to address open comments from them. And for the team for continuing to show up weekly on the discussions to close on the modeling. So the high-level changes we've done, we moved some attributes that are packet-specific to the packet module. We added some additional constraints for the path computation, and we introduced some new attributes for the LSP state and other attributes to do some stitching of tunnels. The first update, we're adding probably I shifted the order on the previous slide, but this is the operational state we're introducing in the LSP. It's basically a state machine of the LSP state as it progresses from path computing to computation OK or failed, and then setting up, and it closes up with a state up. So it's incremental state as it progresses. Right. The second update, we're adding computed path properties, which will hold the accumulative metrics of the path. There are multiple metrics that the path can carry. We have it as a list, and we have a metric type. Metric types that we defined are TE metric, IGP metric, latency, hop count, average delay. Actually, latency and average delay may be the same. So those are identities that we can augment and add more metrics. So once the path is produced, it can have an accumulative affinities of the path, and we're describing those under the LSP, as well as the SRLGs that are collected when computing the path. As well, when the computation engine produces the path, we are going to store the ERO that comes back, or the hops produced by the computation engine, as a list of EROs or route objects. And we're storing this under the LSP again. So this is applicable on the ingress in the case the computation is happening on the head end or the ingress. It's also applicable on the transit LSR, where expansions of the path can happen for loose hops. The fourth update, we added some bounds when doing path computation or assigning some constraints on your path. So the bounds, again, we have different metric types. It's a list where you can set the metric type and the bound that you want, upper bound. So you can basically set multiples of those in the list. The fifth update, in terms of optimization or objective function or optimization criteria, we tried to model what was defined in RC 5541 in the PCE space. So we have an objective function there. As well, we have some more elaborate way of defining an optimization metric that you want, or multiples of those that you want to optimize for. So there was some vendors that thought that we could do, they're interested in optimizing multiple metrics, although some had concerns with that. But so we have these two ways of optimizing for picking a path and applying an objective function. Either you will say, oh, this is my objective function, I want you to give me the optimal path, or you define your own objective function by producing a list of metrics. And you close off if you have multiple paths that your compute engine produces. You want to break the tie between those and pick one of them. You are you're allowed to add tiebreakers. So basically, you go over the paths, you list them by the first metric. If they're equal, you go to the second metric, and you pick the one that the winner basically at the end. In case of ECMP. So there was the sixth update we did was with respect to constraints, basically to realize what was mentioned in RC 3209, and it was specific to the bitmap and not the name name way of computing affinity paths. So we added the usage leaf there to allow for exclude any, include any, include all. So we support in the model these three that are listed in RC 3209 now. The last update we did was with respect to stitching multiple tunnels together to produce an end-to-end tunnel. And for this, we are introducing a label set with a bitmap and an in segment and out segment, basically, in order to stitch on the way in and way out, so that you get the end-to-end. So there is a forward leg there and a reverse leg, and there is an in segment and an out segment. So that was it for the TE model. Next is the RZP and RZPTE draft updates to those two drafts. The summary of changes, we have not made changes to the RZP model.
Should I ask questions about the first presentation at the end or now?
Now is good.
Okay, could we go back one? So just a point of information.
Right.
Clarification, not a suggestion, underline. In your tunnels, you said that was an update for stitching. Did you ever in your tunnels look at points of encapsulation and decapsulation besides labels?
Yes, so our generic TE model is independent of the technology. So our labels can be packet or non-packet. So we try to define the generic model independent of the technology, and then there are other modules that are, packet specific with labels and.
Okay, and this is in the generic one.
Right. So you will notice here that the label is in the model here. The label is a generalized label, and it does not use the packet type. So no updates to the RZP model. There were minor updates to the RZPTE, mostly editorial, in order to align with the changes with the TE model, because we augment the TE model. Now I switched to the open issues. One of them is the migration to NMDA style. We know of one implementation that's ongoing right now, so we want to minimize the changes or the impact on this implementation if we want to do the NMDA migration. We have multiple modules, external modules defined in other drafts and in other working groups as well, that are augmenting our models. So if we go ahead and make a change to the NMDA style, we want to coordinate with them as well and notify them that we're doing this, and they will be impacted. So their models need to be updated and synchronized as well. We have one last point, which is the dynamic created tunnels, which is a system-generated tunnel. So far, in our discussions, we were attributes of those tunnels were going to show up under the state leaves. So we branch config and state
to show the applied and the intended and applied, as well as capture the dynamic. So far, this was the thinking. Now, if we migrate to the dash state module, we were not sure if we're okay to continue showing the dynamic attributes of tunnels, of dynamic tunnels under dash state, or should we have two lists, a list for applied configuration and another list for dynamic created tunnels. So we have a case where in TE tunnels where tunnels are created dynamically by the system. An example is auto bypass tunnels or auto backup tunnels or auto mesh tunnels. These are created by the system, and we wanted to model those.
Okay, Rob Wilson, Cisco. So if you were to move to NMDA style, then when you have an NMDA module, you'd have the config and state in a single tree. The operational state data store would show you these dynamically created entries, because they're not coming from the dynamic data store, they're just coming from the system. That's fine, and you can create them there. So when you create a separate -state version of that module, again, you'd put the dynamic entries in the same one. There's no issues.
The original one. In the dash state or the original?
If you're running an NMDA on an existing device, you create an extra -state tree to serve that purpose, -state module, and you write it there. So effectively, the -state modules, you can think that as being like the short, poor man's implementation of a dynamic data store, of an operational data store.
Yeah, but my understanding is there are two data stores: the configuration data store, and then the applied data store.
Operational.
Operational, and will there be a dynamic data store?
Potentially for I2RS, but only for I2RS. Only
no,
for,
but we have a use case here in this model where we have dynamic state as well.
That's fine. I mean, you have lots of dynamic state in a system. If you have like a BGP
Right.
peer, that's sort of dynamic state. So that's well known and not an issue. That just goes into the same state tree like the rest of all the other state that you have.
Okay, not in the dash state or the -state module. Okay, this is where
This chat offline.
Okay, we need to chat. Yeah, it wasn't so clear where would we put this stuff. So we're okay. We want to move with it. Sorry.
And if you want explanation on the dynamic data store, I'll be glad to help you. We're the folks who wrote the NMDA, the stuff also gave a data store template, and I2RS is creating the dynamic data store. We'll be glad to help you with anything we can. We've been very helpful with the other stuff.
Thank you. Yeah, definitely. We want some clarification on that. So we want to move with the working group consensus on this. So the TE topology model is doing the dash or -state module. We could migrate as well to be aligned once we chat offline and clarify all the open issues. In terms of next steps, like I mentioned, we need to close on the NMDA. We need to continue on working with other team defining RPCs for the tunnel and the path computation. In terms of RSVP based and extended draft, it is stable. We think that it's ready for working group last call. For the other models or drafts, we ask further review from the working group, and we promise to address comments. That's it. Thank you.
Good afternoon. My name is Sergio Velotti from Nokia. I'm going to present update for the path computation request young model on behalf of co-authors and contributors. Okay, this is a summary of the changes we have from the last IETF 19A. So we added consideration for stateless and stateful solution, trying to address comments that we received during last IETF meeting, particularly from Drew. We made a close cooperation with TIE-Tunnel guys, Tarek and the other co-authors and contributors for TIE-Tunnel model. And we resolved some common issue. And we had now a grouping in young TIE types that accommodate also some needs also for path computation. So in particular for young RPC update, we redefine as an augmentation of the tunnel RPC. So our RPC is provided as an augmentation of the tunnel RPC. We align our grouping in young TA types, common grouping, and other support for multiple path computation request using more or less the same concept as VEC in PCEP with the synchronization list. Okay, here is there is the GitHub support with the link, and we use this support for tracking young model for state RPC and to track also issue. And we track some opening. We have some open issue, but we solve some sudden open issue with respect to the last IETF. And there are other 5 that are being discussed jointly with the TIE-Tunnel model. This is the basic open issue that we are still in discussion with TIE-Tunnel guys. The first one is for topology D. We solved the problem of what is the meaning of topology D. It is clear. So with Tarek. But the follow-up question is how to use this topology D in the sense how can be chosen this topology G to be used, and if it is the case that an MDSC or a hierarchical controller can decide to request TIE-Tunnel setup in topology 1 or 2, depending of path computation that has been provided before. So this is has to be discussed with the other guys. So other issue is related to the request for to shrink a little the tunnel parameters config list of attributes that we should we cannot. It is useless. No, it is not useful to use for us because there are a lot of attributes that are not needed for us. And we agree to have a separate grouping that can be reused by the path computation module specific. And we need to finalize the list of attributes that is real needed for us. Then there is a residual bandwidth open issue that there has been provided by Daniele a presentation about this in PCE. This is for us is general T concept, not just for PCEP. And we think that is a new metric for a minimum reserved bandwidth and can be help to minimize the number of path computation requests. Then there is the request to have a relaxable constraint concept. So in PCEP, there is already this feature. And that providing the fact that a path computation must fail if a constraint is not met, or in case it is relaxable, constraint can be relaxed, so the path computation does not fail. So needed again some needed also for path computation RPDC, and has to be discussed is that can be bring into the context of TIE-Tunnel model. The other issue is related to the class type. Class type is defined actually in the TIE-Tunnel model, but is correcting the augmentation of MPLS. we need also to have an augmentation just for packet MPLS path computation, but we need to understand in which document, because actually in the TIA tunnel, the document is the same. There is a separate model, but is in the same document. The last one is the missing local protection. So we would like to have local protection also here in the context of path computation, like the usage for RFC 320109. This is already covering for the TIA tunnel regarding in case it is used the signaling to set up the tunnel, but we would like to have this feature independent of the fact that you use signaling. So in the case of TIA tunnel, in case of LSP static. Okay, next step. Obviously, we need to resolve the open issue that is still open. So continue collaboration with the TIA tunnel authors. Obviously, need to have further comments and feedback from working group. So that there is the basic an issue that discussion regarding the need to reduce the number of path computation requests, but we think that this is an implementation issue. It's not a problem of standardization. Our view is try to have a tool set, so encompassing both TIA topology, TIA tunnel, and RPC path computation to create this tool set to provide in the hands of for system use. Okay, so I think that we think that the draft is in a good shape. The young has been extended, and so I think we can be ready to become a working group.
Questions?
Igor Breskin, Huawei. Thank you, Sergio, for summarizing all these issues. There are some very important ones and useful, like, for example, the lack of order of relaxation of constraints that is definitely missing, and it's quite easy to address. There are some issues that I think it's just misunderstanding, like, for example, the last one that you said about protection. I don't think that we actually related to signaling in any way. So when we model T-tunnel model, we do not assume that it would be signaled by some protocol. And protection, local protection, end-to-end protection, it's not only important parameter for provisioning tunnels, but also for path computation and stuff like that. So some of these things is just we could just figure, talk and straight it. Yeah, the thing about topology idea, I didn't even understand.
Already provided also in case of LSP state.
Yeah. Basically, what you're saying that it is missing in the LSP state.
This is my understanding.
All right.
Understanding,
Okay.
With Tarek.
Okay.
Pavan, this is a more general comment, but it is highlighted by this gentleman's slides. The base topology, we're going through the final working group last column publications of the base models and hopefully the TE base model. One of the things the Yang doctors asked us is, were we doing RPCs or were we doing just reads and writes? This one seems to focus on RPCs along a train. My understanding is the base model needs to be able to do reads, writes, and RPCs. Do I understand that in your work? And that's just it's a point of question because it's part of the standardization process of the base.
Yeah, but given the topic discussed in the draft, RPCs is what they're shooting for. We will run it by the young doctors at some point, but it makes sense to have RPCs.
I totally agree that this makes sense, RPCs. It was just a question whether you're going to continue to keep the base model
Yeah.
all three.
Yeah, at this point,
That-
yeah, we have RPCs in all the base models.
You have RPCs in all the base models, but you will allow edit rights in the base models as well?
Yeah, we are not precluding them at this point.
Yes, thank you very much.
We typically don't gauge interest for a document in a joint session, but given the overlap of the topic with PCE, we're going to make an exception. So I'll do a quick poll. How many of you have read the latest version of this document? Can I get a show of hands, please? A few. Of those who have read the document, how many think that this is ready for adoption? See a few more hands than last time, but we'll take it to the list. Thanks, Soji.
Short comment. So in routing working group, we've adopted practice to review document externally twice. Once when it's process of being adopted, and second time before working group last call. So rather than waiting till working group last call and then going to young doctor, you might want to review it with external party while it's going through working group adoption. So you don't want to focus on something that might be changed very close to the end.
Yeah, we don't have a set policy on that yet, but yeah, it makes sense to get the young doctors involved as early as possible.
It makes quality of documents significantly better.
Lou Berger as chair, T's co-chair. One counter to that is if you do it too early, you're getting feedback on something that's immature, and you may change in a radically different direction. So as long as you're making the young doctors know that it's very early and something radical might be coming, that we don't waste their time.
There are other people who know young besides young doctors. So you might keep young
fine.
doctors.
That's a great point.
Are you volunteering to review the draft?
For the record, Jeff said he will review it, so thank you.
Italo Buzzi from Huawei. Lou and Papa, maybe we can share the document with PC because we have got the questions in the past that we need to keep a PC working group informed since there is some, let's say, common expertise to be addressed.
Yeah,
I think we can do that as authors. It's not a problem.
Yeah, so we've come across this before, as you say,
Yep.
and we've had the agreement with PCE that T's would, as its name implies, focus more on the
Yep.
architecture side, and they would do the PCEP side. This is a little different because it's mechanism for both.
Yeah, this is a young model, but young model is in
Yeah,
T,
so-
is in T, so I think it
it's a
fits in
good
T's,
point.
but it's good to keep a PC working group informed.
It's a really good point to raise. While we're running these joint meetings, it makes it easy to just keep this discussion in here. I'm not sure if we're gonna, we say this meeting's an experiment, so we'll see what happens, and we'll make sure. Thankfully, we have the PC chairs here, so we'll make sure to coordinate with them.
Okay.
Just for the records, the authors put together all the open issues and sent them on the mailing list. So if you want to contribute to closing those issues, you'll find them on the list.
We're jumping to the CCAM drafts now.
Yeah. Hello. This is Young Lee. I'd like to give you an update on WSN topology Young model. Actually, we try to augment the base T topology model on this particular update. That's a major update, and we claim that it is NMDA compliant, as T topology claim that they are NMDA compliant. But I think we found some issue on some. It compiles well until T topology update was taking place. So we have some glitches here for the namespace on, I think, some of the, after network types, we have /WSN topology. I think we probably need some prefix on that, so we'll fix that. And other than that, we didn't have any other update. But I think I remember Dieter mentioned that default frequency should be anchor frequency. So I haven't changed that. I forgot about it, but I will change that in the next revision. So this is update. And I think we need to continue to, make some effort to align with T topology, and then kind of copy whatever you choose to do, and we need to kind of reflect. Also maybe appendix issue as well, but this is simple model, so I don't know. I need to talk to Shufeng how to do that. Okay, any comments on this model? Okay,
once the T topology is approved, once the T topology is approved, what's left to do in the draft?
Oh, that's a good question. Actually, we don't have impairment validation model here, although in WSUN GMPLS work, we actually have that aspect. So if people feel we need to add impairment validation for linear parameters to be added onto here, we can do that. Or there can be a separate Yang model and augment this model. So either way is fine, but that's something that we need to talk in CCamp more detail. Okay, it's not this issue, so I'd rather not talk about too much here, right? Because after this, we have another meeting, right? Yeah, okay. Oh, actually, I have another oh, actually, I sent integrated model for WSNT model. You don't have that? This is the last page? Okay, okay, great. Yeah, this is the first presentation of T-tunnel model, which is basically augmenting T-tunnel model that Tarek presented. So the model name is IETF-TE-WSUN, and it augments T-tunnel model. And it is not yet an NMDA compliant model. It's going to be also pending T-tunnel model. So this is a basic model that we added. We have 4 containers for tunnel configuration and tunnel state, and the LSPs and device configuration. Quite simple. It's not complete yet, but we just started as a base for 0.0 and 0.1 version. And we need to continue to align with the latest updates from T-tunnel. And any comments? And I think this might be a good base to get adopted, although it's just initial version. But there might be some CCAM issue in this afternoon, but I'd like to have this model adopted and move on.
We have Dieter in the queue. Let's see. Dieter,
hello,
speak.
can you hear me in the room?
Hello, can you hear me? Yes, now we can.
Okay. I actually have a question regarding the CCamp WSUN Yang draft. It defines a connectivity matrix for WSUN networks. Question is, why don't you reuse the connectivity matrix that is defined in the T topology Yang model? Why is it redefined for WSUN?
Yeah, I think, when you started this one, this is a technology-specific connectivity. And it has a little bit different implication because here connectivity is a node connectivity, coming inside and coming out, interface and outside. So we have a little bit different implication from topology connectivity matrix. That's the first take. And also
yeah,
we are talking about...
I think it's pretty much the same like in the T topology model.
Yeah, it could be. So I haven't looked at it. So in terms of, we actually augment. Yeah, actually we augment basic connectivity. So we do, yes. And then for interface type-wise, we have to specify WSUN interface reference. So we do. Okay. Yeah. connectivity matrix. So we do. I'm sorry. Yeah.
Yeah, I was asking why this augmentation is needed and why can't you reuse what's already defined in the TE topology model? That was my question. Why do you augment? I don't believe that it's necessary, but we can take that offline.
Okay.
Sorry, just Igor Bruskin. I agree with Dieter. Basically, today in the connectivity matrix, we have all the parameters, including, for example, label limitations and everything that in our view is sufficient pretty much for all layers across the technology that we use. Okay,
yes,
so there's no really need for augmenting this particular piece of information.
Yes, I think this is a bigger issue, I think, because when we write this model, we assume that abstract topology will have a generic model, not technology specific. But I think over the time, you guys included very specific encoding. So that's some issue that CCAM need to resolve. Because this was written before you guys have connectivity matrix, because this is inherited from GMPLS. So we can take that issue in CCAM more. Okay.
That was the history, right? You started with the optical layer, then we realized that it's not basically only specific to the optical layer, and it's also applicable to multiple layers. And then eventually it is also very applicable to abstract nodes for pretty much any layers when you have like a...
Yes, I agree, but I think a charter for T topology is generic model. So I think you are actually violating those multi-layer assumption. So either way is fine, but I think we need to make it clear on that. Because we have other OTN and Flex Grid, those guys are defining their layer-specific topology and T-tunnel model. So I think Louis is here. I think we need to hear what he has to say.
Well, we are discussing with Dieter. We are discussing a particular this like a first WDM layer specific model. If the say a FlexiGrid will need some more information, then it would be a reason for augmentation. But so far, neither me nor him nor anyone who is involved in the T topology model discussion see a reason for this augmentation.
We have Dieter in the queue again. You will be able to speak after Lou.
Hi, Lou Berger. This is like a classic discussion we've had in CCAMP since CCAMP started, where we come up with something that is technology specific, we get it nice and polished, and then once we have the solution and gone through all the difficult details to solve it for that one case, we have to take a step back and look at it and say which of these things are sort of generic and belong in generic capability. So from those who are working on it, it absolutely always feels like they're done at that point. That they once they solve it for their technology, they're done. But from the common and from the way we've done things in a generic way, it's when they're done that they have to take a step back and say, we have to separate this. We now have enough understanding about how to abstract the piece to the generic. And it's always tough for the people who are working the problem because they feel like they're done and they just want to ship it. And you have to respect that. They've done their hard work and they want to have a solution and move forward. But part of our standard process is making sure that we, at that point, have the aspects that are generic, represented in a generic fashion. And this is a constant struggle and tension in CCAMP, but I don't see it ever going away the way just because you deal with specific technologies. It's a tough thing for the working group to manage, but it's really important because if we don't do it, we don't end up with generic capabilities and reusable capabilities.
Sure. Okay.
Dieter?
Yeah, I have one more question regarding the connectivity matrix. Typically, the connectivity matrix is there because it reflects system limitations like switching capabilities in the photonic switching fabric of a WSUN switching node. My question is now, this seems to be a configurable node or attribute. Connectivity matrix is read-writable. So my question is, shouldn't that be a read-only attribute?
Yes, I'm sorry. Yeah, for this topology model, yes. For the T-tunnel model, configurable, correct. I think you're right. this should be read-only.
Igor Bruskin. So to answer your question, say for physical RODOMs, this is probably true. But for example, you can see a node as a representation of optical domain, and then you actually can configure the desirable connectivity metric. Okay, so you may administratively limit, for example, various reachability from one interface to another. You can also differently optimize the connectivity metrics. For example, different paths could be selected if you want to have like a different optimization criteria. So for these reasons, we in the base T topology model, we make it configurable. Okay, but for physical RODOMs, this is probably limited to just learning what is possible and what is not.
Okay.
Yep.
Which presentation?
Yes. Just a correction to the agenda. The draft is now a working group document. The OTN tunnel model became a working group document right before the start of the meeting.
Good afternoon. My name is Zhou Yufan from. Oh, sorry. Good afternoon. Can you hear from back? Okay. My name is Zhou Yufan from Huawei. I will present two drafts for OTN young data models. Basically, these two models have no technical changes since last IETF meeting. So I will briefly introduce these two models. And for the for OTN topology young model, is augments T topology model but focus on the electrical layer of OTN, which is audio layer. And in the model is we define the OTN topology network type. So when the network type is OTN, and we have a name with a string type for networks and nodes, and available audio information for link attributes actually, and also audio termination point information currently is under link termination point, but in the mailing list, Igor suggested that it should be in the tunnel termination points, and this is a young tree from the topology young model, and for the link attribute, currently we augment the old version of the T topology model. We will update this model and change the path, and also move the available audio information to the link attributes container. And this is audio termination point information, and including the adaptation types and tributary slot informations. And yes, no technical changes since the last IETF. And next step, we will address the audio termination point issues and change the model to be NFDA compliant. For the OTN tunnel model, this draft is recently adopted by the working group, and the working group version 00 has been uploaded, and this draft contains two young models, and one for OTN tunnel, and there is also a model for transport types, including client signal types and tributary protocol types. And the OTN tunnel model also, the OTN tunnel model augments T tunnel model. Okay, and for the OTN tunnel model, we have a tunnel we have attributes for tunnel endpoints. Some of the attributes are for actually for multi-domain scenario, like the payload treatment attribute. It indicates that whether the service in the tunnel is transported through this domain or it's switched to another tunnel or the audio tunnel in this domain. And the client source client signal and destination client signal can be different to indicate non-bookended OTN tunnel. And this is part of the this is a okay.
Igor Bruskin, Huawei. When we started working on T models, T tunnel models, and T topology models,
yeah,
we adopted strategy to produce layer-specific augmentations, right? And over last couple of years, and especially this several months of intensive discussions, we came to conclusion that this works pretty good for T-tunnel model, but we have serious problems with layer-specific augmentations for T-topology model. One reason for that is that, for example, in the same topology, links could belong to different layers.
Yes.
Okay, and it's not clear what kind of augmentation you would use if you have in the same topology, say, OTN and OCH layers, OCH link. Furthermore, access links could be multifunctional. Depending on configuration, they could belong to 10 different layers at the same time. Okay, it could be Ethernet, it could be SDH, it could be FCON, right? So again, it is not clear how do you do that. So what we started working on, and what we seems to come to conclusion, it is better to introduce layer-specific types rather than layer-specific augmentations. And we started doing this by defining, for example, groupings for bandwidth, okay, that describes bandwidth for different layers as a choice statement, so that in the same topology you can have, for example, links belonging to different layers, and so will happen, I predict, for TTPs. So this is a very important question, how to go about that.
Yeah, actually, that's a very good information that we just learned since last IETF meeting. So where do you keep that type? In a separate Young model?
Yes.
Okay, and then you just reference that.
2 types.
Yeah, I think that makes sense. You know, in my opinion. Yeah. Okay.
Hamid from Huawei. I think to provide a few follow-up to Igor's comments, we really hope to see a kind of stable T generic attributes, and including both the parameters, augmentations, and the types description, so that we can, based on this kind of generic T parameters, to generate those kind of layer-specific techniques, including both WSON and OTN. Thank you.
So, Igor Bruskin, so basically what we are saying is that it is fine to have layer-specific augmentation. For example, say it is fine to have, say, IP MPLS layer-specific augmentation for topology, but only if it have like a new constructs, in addition to what we produce in the base topology model. So, but for example, if you want to have more attributes attributed, say, to links or tunnel termination point, it is better to basically define less specific types and not to use augmentation at all. Okay, so augmentation, again, you need it, for example, various like a FRR kind of considerations, which is specific, say, to packet layer, but not to other layers. But say if you want to have, again, layer-specific parameters for a link or TTPs, I think it is better to do, which is pretty much similar what we used to do in GMPLS, okay, when we defined layer-specific TLVs. Yep.
Huawei again. Just want to add more sentence. I think that at least for the parameters listed on this page of slides, almost all the parameters are from the existing RFCs, and we're not creating any additional stuffs.
Okay. So okay. I think maybe we can make this as an open issues for the future, for the later versions of maybe these two graphs.
Can you speak closer to the mic?
Okay, sorry. Yes, I think we can make this as open issues for discussing for these two graphs. And actually, I'm almost done. And the next step is for the OTN tunnel model, we will follow the T tunnel model when it becomes MBA compliant. Yes, and that's all. Thank you.
Now we have a remote presentation. Nicola, are you there?
Hello? Can you hear me?
Yes, everything okay.
Hi, fine. So this draft, hello to everyone. So this draft presents young model for events, actions, and finite state machine. Okay. So this has the objective of increasing the programmability of network devices for devices modeled with Young. We found in particular one use case is related to flexible transponders. So flexible transponders support multiple rates, multiple modulation formats, and FEC. In particular, modulation format and FEC can be set based on optical physical layer. So, for example, QPSK is more robust than a 16 QAM, and it's possible to readjust these these transmission parameters of modulation format and FEC if something at the optical layer changes. So, for example, some parameter is degraded due to aging or something like that. Yeah, thank you. So the scenario we are considering is referred to the UBNO architecture, where in particular we have an SDN controller that configures and reconfigures data plane devices, while the O&M handler receives and processes the alarms in case of some problems, and if needed, triggers the reconfiguration for the maintenance of the services. So, how can change from my? Okay.
No, you're not allowed to do so. Just ask.
Okay. So, considering this scenario at the state of the art, without assuming the model of this draft, if let's assume to have an active service connection, then we have a degradation of the physical layer, implying a bit error rate increase. Thus, this degradation of the service performance are detected, and an alarm is sent to the O&M handler. At that point, new transmission parameters are computed, and after the SDN controller goes to reconfigure the data plane devices, so the transponder. And at that point, the service is recovered. So you can see that that this workflow implies several tasks, so can be time consuming. Next slide, please. But if we apply the young model in this draft, we can do something different. So while the active connection, while the connection is still in service, the SDN controller instructs the data plane devices on the actions to perform if an event happens. So, for example, if a degradation happens, the SDN controller instructs these devices on how reconfigure themselves, so that when the degradation happens, the recovery can be faster. So this can be done with models for events, action, and finite state machine that can be included into netconf messages, edit conf message, for example. Next slides, please. Thank you. So this is the tree of the young model for event. One leaf is the attribute event that it is a list. So, for example, we can have the event bit error rate increase. The attribute, the subleaf filters can be used to further express the event. So, okay, we have a bit error rate increase, but which impact? So this filter can be used to put a threshold, so that we can identify if the bit error rate is higher than this threshold, so can be a problem, effectively a problem, and a reaction should be done. The reaction in our use case can be the change of the modulation format, and the attribute execute actually recalls an RPC where the task is encapsulated. So the young model for the finite state machine extends the one that in the previous slide by including the state information and the transition. Next slide, please. Thank you. In the lab, we installed the finite state machine into the local controller of transponder in a control plane testbed. In practice, assume to have a steady state condition where the network and the service works properly. Assume to have an event of bit error rate increase over the threshold, so we have to take the reaction of FEC adaptation, and at that point we transit to the new state, which is FEC adapt. But from this state we can come back to the steady state if the bit error rate returns below the threshold, and in that case we can reduce the redundancy of the coding. So that's it. This is well, we can stop here. Those are further slides, but I think we can stop here, so we have enough time for discussion if there are comments and so on. In particular, if there are suggestions for other use cases. So since this model is in practice is generic, if there is interest and suggestions for other use cases, the comments are welcome.
Thank you. Thank you. Before starting, can you mute Nicola? Thank you. Thank you. So before we start with the questions, this draft was linked to CCAMP, the OPSA working group, and the SUPA. because well, to CCAMP because it started from an optical use case, but it's for sure this is something that can be generalized, can be used in a lot of different contexts. So as in CCAMP, we would be happy to see technology-specific extensions, but probably this work needs to be done in other places. I don't know if the OPSA working group is the right place, or NetMod could be one. Lou is contributing, moving his eyebrows. No APR. So, but this is something we can. I mean, I just wanted to give you some background to the slide, to the draft. Homian, please.
Okay, thank you, Homian from Huawei. I have a question for clarification. Considering the mechanism you deliver in the presentation, my feeling is you are trying to optimize the message flow in order to improve the performance.
Sorry.
So
sorry,
is
in
it
order to improve what? Sorry.
To improve some kind of performance parameters.
No.
Or are you providing any additional functions, or you just try to optimize?
No. Well, it's not exactly. It's not really a problem of optimizing performance, some performance parameter. The performance parameter, we can say that the performance, we have some performance parameter to monitor. This performance parameter has to stay inside an acceptable range. So it can be, it's enough that it is in this acceptable range. While it goes outside this acceptable range, becoming critical, so creating problems to the service, problems in terms of quality of transmission, thus quality of service, we have to take some actions. So it's something, the use case finally is something more related to the maintenance of the service, in my opinion.
Okay, thank you.
Thank you.
Greg and then Dieter.
Yes, Greg Mirsky, ZTE. So Daniel, I very much agree with your statement that it will be good to extend and look at the generalization of this. I can point to a couple things. First, probably work on LMAP that defined their framework, and it has an informational and data model for controller that performs performance measurement and then passes the information to collector. So the collector can be the one that monitors quality of the service, and performing measurements, it uses new performance measurement registry. Another thing is that in many cases, especially if we talk about packet network, then it would not be only one metric that will be monitored as a characteristic. So the mechanism probably should be looked at extending, having the policy that combines multiple metrics and then defines an ability to define in and out of degradation state.
Yeah, thank you. Yeah, packet.
Actually, I would like it to be, because it's a very good idea, and I was looking for it to come up.
Thank you very much. Yes, as I said 2 days ago, yeah, in the OPS meeting, yes, the work started with optics, but finally we tried to make it generic. And yeah, for sure, the packet networks are something that we should think about because it's important and can be a use case. So yes, thanks. We will think about, and if you find some, I will start some discussion in the mailing list. If you any contribution, any comment on the use cases is welcome. Regarding the performance monitoring, that work that you cited, in my opinion, can be can stay in parallel to this work, because we are not defining any way of monitoring, but our system will exploit some monitoring system, so they can go in parallel, in my opinion.
Dieter is next.
Yeah, I have a question regarding the use case that's used here as the major motivation for this work. As I understood, you're saying that the optical transponder can actually autonomously change its mode of operation depending on the signal quality. Typically, when the signal degrades, you have to switch to a modulation scheme that also has an impact on the service data rate, meaning that it's typically reduced. Let's assume that you have an optical transponder that's capable of carrying 2 times 100 gigabit Ethernet, and in case the signal degrades, it will only be capable to carry 100 gigabit Ethernet and not 2 times 100 gigabit Ethernet. This means that this has an impact on the service that has to be dropped, and I have doubts whether this should occur autonomously. I would prefer that an SDN controller or a network management system subscribes to receive telemetry data from this optical transponder, and that an alarm is raised, and then in case the signal degrades, then either the SDN controller has to make sure that the traffic that cannot be carried any longer by this optical transponder needs to be rerouted, or that the operator takes other consequent actions rather than letting the optical transponder to do autonomous consequent actions that may impact the traffic. Typically, these degradations are increasing slowly over time, so I don't expect that these changes will occur very frequently. So that those are my comments.
Yeah, this comment is very important. Yes, for example, passing from 6 QAM to QPSK without an additional carrier, optical carrier, we would have half of the bit rate. The same would happen if we work at fixed baud rate and we increase the redundancy. Consider that this work, this use case, comes from a project called Orchestra, where involving operator and also vendors, and one of the use cases of the project consider that we have at the optical layer some service class that admits the reduction of bit rate in case of specific events. So if we look at the literature, we can find justifications for that, despite Telecom Italia, and which is in this project. I found justifications from that from Nokia in a paper of last optical fiber communications conference, and which is also in this Orchestra project, Nokia. And there is also some other justification from Deutsche Telekom, another paper cited in the one by Nokia. Anyway, this is a case, is just a use case. We are thinking to a way of enlarging the filters, because if we need to keep the same bit rate, we would need one carrier more, something that the sliceable transponders admit, but we will need to enlarge the filters along the path, and we are thinking to an execution task that will imply also the enlargement of filters.
Okay, we have 2 more people in the queue, then we will cut it. Amy?
Thank you. Amy from Huawei. I have a question regarding, I understand what you want to achieve, but I don't understand why you would do in that way, because you would like to speed up the reconfiguration. This could be done within the data plane. You don't have to have the interaction with the control or management plane. And so this is a point that I couldn't understand. And the second comment is that I think, as mentioned by several people, I think in this case it's kind of some generic, and we are also working on the microwave radio link, and it's have a similar feature which will be automatic changes the modulation level due to the external conditions. So there's a possibility to make it more generic.
Thank you. Thank you for the comments. Regarding your first comment, sorry, but I don't see another way to readapt transmission parameters without going to a centralized controller. But maybe I'm wrong, but I don't see another method currently with the current state of the art. We have to pass through a centralized controller. This is time consuming.
Well, I think you could make the decision by the node itself, and if you find that the current BI is lower than threshold, then the node could adjust the modulation to the whatever.
Maybe you can do in a proprietary way, but the objective of the work is to reprogram these devices in a vendor neutral way. I think it's not so easy to do that without something like that, or without passing through a centralized control.
Well, at least this is a common technology which is widely used in our microwave links. So I think maybe we could talk more offline.
Okay, thank you.
Thank you.
So a few comments on extendability and being more generic. So you might want, rather than enumerate your use cases, to split them into another model, and it will give you ability to scale better. It will be more easily to consume, especially as you go into packet layer. Number 2, today your condition is binary. If you go to packet layer, it's not going to be binary. You really need to understand what it is. So it's not just false or true. Number 3, and back to Greg's comment, usually there are a number of conditions, so you should be able to do something like logical AND or logical OR to come to the conclusion action. So it's mostly about extendability to higher layers.
Sorry, I didn't catch well the comment from my side. I'm sorry. Can you repeat, please?
So number 1, today you're only focusing on optical. A number of cases is low. Yeah. As you go in the layers, become more generic, it will become much larger space. So you might want to split out the cases.
Okay.
With regards to actions, today they are binary. it's either false or true.
Okay.
So you might want to be able to look into gradual degradation. Number 3 is ability to combine different events.
Okay.
And
so you are saying you are telling me some suggestion for usage of this model.
Yeah, if you want to become more generic and across layers.
Okay. Okay. Thank you.
I see Dieter on the line. Dieter, if this is use case specific, please take it to the CCamp list. We're going to start with the next presentation.
So thanks to all.
Thank you.
Bye-bye. Thank you.
Here you go.
Hi, so my name's William Lupton and I'm speaking here for the Broadband Forum. Just to give an update on the Yang work that we're doing and how it relates to the Yang work of the IETF. Okay, so these are the questions I'll try to answer. So what is it we're working on and what would we not work on because we would regard it as out of scope? What are we currently working on? What have we published? What are our sort of ongoing projects? How do we publish it and where are Yang? What about drafts? Because as people probably know, the Broadband Forum is a member organization, so the work does not take place in public. What about the Yang catalog? Are we putting our stuff in the Yang catalog? I expect you'll guess from the fact the question is there that the answer is yes. And then also just a bit about our practices, our ways of working. What rules do we impose on ourselves? What about using external Yang and that sort of thing? Okay, so our emphasis is on addressing requirements of our BBF projects rather than on providing general solutions, which I guess is a contrast between us and what you might call core SDOs such as IETF, who I think at least in some areas, particularly in NetMods, definitely have an ambition to provide general solutions that will be generally useful outside of IETF. Currently, the emphasis is on broadband access nodes, so nodes in the access network, particularly, or for example, more requirements from those two standards, TR101 and TR301, and you can see what those are. So what will we do in BBF? We'll define Yang for our own protocols that we've defined or interfaces that we've specified, but we'll also define Yang for non-BBF protocols or interfaces if the owner organization is sort of not interested in defining it and is happy for us to do that. And that's been the case for some ITU-T physical layer standards, for example. And also we will reuse Yang from other organizations whenever we regard that as being possible. What are we working on? What have we published? Well, this is just a quick outline of our current Yang-related projects. I won't go through them in detail, but you can see the top two have been published. And there's also one, that pond management one, we've published a draft there. So all that Yang that's been published is available for anybody to see. The Yang from the other projects is not yet available, but I will be talking about that a little bit more. Just a little bit more on the two we've published. So the first one was what we call TR355, which is Yang modules for FTTP. That's fiber to the distribution point, which is like an access node that's very close to the home and serves multiple homes. It might be mounted on a power pole. And what we were mostly doing there is actually publishing defining some Yang for some physical layer interfaces that have been defined in ITU-T. So these being the physical layers that are used for this type of device. And so we did this depending on the IETF interfaces and also the INET and IETF Yang types from IETF. And we're now working on a new version that sort of adds some more stuff. Bonding and reverse power feed means that these devices can actually be powered by the power supply from the homes that are using them. So just to give an idea of what the scope of that was. And then
Lou Berger, can I go back one slide?
Yeah. Sorry.
So this brings up a topic that actually didn't come up when you presented this the first time, but it follows some discussion on the NetMod working group list. And it's good information for this group as well. Are you aware that IETF interfaces is going to be revved?
Oh, yes.
Okay, good.
It did come up
so I have no memory. I've just
the NMDA thing.
Yeah, exactly.
Yeah.
So it's good for us also for this group to know, to be aware that the IETF interfaces is going to be rev. And if you want more information on it, look at the netmod list. There's discussion on it.
But I've seen
Thanks.
that, I mean, several of the contributions this afternoon have had a section on sort of NMDA implications, right? And the temporary state,
and I just wanted to highlight the one on
module.
interfaces
Right.
because it's so basic and make sure that BDF was aware of it. That was really the point.
We are now.
Great, thank you.
We are now, and I think certainly IETF interface is one of the main ones that will impact us. The other one, which is not currently an RFC, is the entity, the IETF hardware one, which also has that same state separation. So absolutely, we've got to go back and decide our reaction to this. But I think our reaction is likely to be similar to that of the working groups within IETF. I think we're likely to consider the same guidance that's being given internally.
Right, and it's halfway done the split. It just didn't make it.
Yeah, but the difference between it being halfway done and done is that I believe you won't deprecate the state tree, you'll delete the state tree, right?
The update is halfway done. It wasn't published, so if you went and looked in the repo, which is publicly available, you'll see it partially done, but not completely done. That's what I meant by halfway.
Sorry, yeah. Sorry, I thought you were just distinguishing an RFC and an ID there, right. Okay, so so absolutely, yeah, we have to definitely consider how to handle this this ball you've thrown at us. So the other one we published is, I mean, I don't necessarily expect you to be able to read that. It gives an idea. Each of those boxes there is a module. You can see the imports. You can see that the blue is the sort of general areas, the general topics, and you can also see the external dependencies on IETF, which this time does include the dependency on IETF hardware. So this is what we call common Yang. So the idea is that this is sort of roughly equivalent to the sort of thing that might happen in netmod here, but goes beyond that a bit. It's really Yang that we see being used across multiple of our work areas. Even if some of it is actually quite, I mean, like you can see there's some forwarding modules in there and that sort of thing. So it's not all just pure core stuff. And we're working on some new stuff too now, and I've listed some of the things we're working on. I'll particularly mention the one at the bottom, alarm management. We have a strong interest in the IETF alarm work, which has been moved to CCAMP, but the draft hasn't yet been updated in CCAMP, so it's not on the agenda. And anyway, I wouldn't have been able to go to the CCAMP meeting because it conflicts with the NetConf meeting. Anyway, so.
Since it's an individual contribution, we cannot force anyone to submit a draft.
Yes, well, let's just hope that before the next meeting.
If you really want that draft, please reach the authors.
Sorry, please.
Reach out to the authors.
Yeah, I have in fact done that. One of them's sailing and the other one isn't here. But yeah, okay, yeah. But certainly, hopefully before the next meeting, yeah. And actually, the alarms is something we're very actively discussing internally. I mean, we're definitely want to build our work on top of the so-called Valium draft, the IETF alarms draft, but we haven't quite decided yet to what extent we want to purely augment it versus bringing some proposals back into IETF. Okay, so how do
Lou Berger again? There's an opportunity there. You can submit an alternate individual draft.
Yes, but I think we'd like to work with the authors of this draft.
Just note that it's not a working group document. There's no.
Yes.
Okay, great.
We have some ducks to get in the row in a row first, though. I mean, you know, because we're multiple members currently discussing various options. We need to get those aligned before even those individual members as contributors would bring that into IETF, I think. But yeah, now I do realize that the thing to do here is not to just say BBF would like this, please do it, IETF. We do absolutely realize that that doesn't work. We realize that we or our members have to bring the proposals in. We really do understand that. Okay, so how do we publish it? We have like an internal software release registry, which is just a grand name for a wiki page, which does list all our published software. Which includes both draft and standard Yang, and we publish BBF Yang to one of our own public GitHub repositories, but with draft and standard areas within it. But we also have that linked in to the sort of de facto standard Yang models area via this thing, a Git submodule, which is essentially a pointer within Git to another module, another repository, which I think is a good way of doing that. And there are some examples in the background slides. Okay, Draft Yang. We have made Draft Yang available for some projects. Just noting there that the Draft Yang we make available does have a different license because we're not wanting it to be used. We're not making it available publicly to be used in implementations. We're making it available publicly to get feedback and to tell people what we're doing. And we are working on making that such draft Yang more generally available. I mean, we want it to be the general rule that it's available for all projects, and what's more, that it's updated reasonably frequently. But that's not happened yet. The Yang catalog, I sort of did this more for NetMod, but all the BBF Yang, the published BBF Yang, is in the Yang catalog. And I'll just quickly flip through the next 3 slides just to show it's just an example of a query for something that was cunningly defined to only come up with one result, and then to show the impact analysis. And what that's doing is it's showing a draft module, which is excuse me, I'm colorblind, but I think it's green, both depending on one of our published modules and an IETF published module. And you can see also that you can go right back to the documents and so on, are all referenced there. So that's mostly a plug for the Yang catalog, really. We do have a policy that that our modules must use standard IANA, IETF Yang modules whenever possible. And we do by that mean more than just importing them. We do mean using them as they were intended to be used. And I've already mentioned these, but I'm just pulling them together here. So the ones we're currently depending directly on are the INET types, the Yang types, IF type interfaces, and then in a draft, the hardware, and then also system. And I already mentioned that we're also in progress. Yang is also planned to depend on the alarms draft. And I think finally, we also have an internal sort of best practices document, which is sort of the broadband forum equivalent of the RFC 6087. And indeed, it's based on that and adheres to it as much as possible. I mean, it's not just specific to IETF, but right now, IETF is the main SDO we're looking to, well, the sole SDO we're looking to. And so some of the categories we have in there are qualifications to or extensions of RFC 6087 BIS guidelines. And we also have some additional BBF specific guidelines. We do have a plan to share this with IETF, but we haven't quite yet worked out how to do that. And the background slides have some specific examples of some guidelines in those 2 categories. And I believe that's the end. And so I don't know if I was too brief or too whatever.
Perfectly in time.
So if there are any, or maybe this is for you to ask, if there are any further questions.
Any questions? I think we are done. Thanks.
Okay, thanks very much.
One question.
Sure, comment. So a few ETFs ago, we've quickly discussed possibility of start working on D1 related data models. I think BBF announced this morning that they're going to create some open consortium. So we're really interested in cooperation, working together.
Okay, sorry, what was the category of data?
SD1, software-defined one.
SD1, right. Well, we do have, yes, right now, most of the models we're working on are sort of pretty low level. We do have an internal, I'm not sure what I can say. Yes, I mean, these will be new projects that I'm not sure how many details are publicly available. But I think what I can say is that whether this would be an example of this, but we do want to be flexible in sort of how we work. And let me just put it this way. I hope that we may be able to create some projects that are not even necessarily just restricted to members. I hope that we'll be able to create some projects that provide a way of non-members contributing directly to those. Now, whether that would be the case for what you're talking about, I don't know. But we do recognize the problem of for some people of us doing the work in a
At some point, we'll start working on data model for advanced service definition in ATF, so it would be great to do it together.
Thank you.
Thank you. That brings us to the end of the session. Thanks everyone for participating. We will see you all in Singapore. Teas in Singapore.
Maybe to the oh, it's here? Oh, that's good. Almost every RF.